learning side of this project. And
are you live streaming already?
Hey, Khalil.
Good afternoon. I'm not, yeah, I'm still kind of like setting up equipment. So I hope we're not live already.
I think we're live.
Interesting.
It just went on without getting confirmation from me. Like on
Okay.
YouTube, it was not supposed to.
Okay, just give me a second.
Don't worry, just take your time. All right, just setting up a couple more things. Then we'll be good to go. All right. Yeah, sorry, folks, there's a slight technical problem. I'll solve it in a second. Then we can get started. Shouldn't take more than a couple of minutes, tops. Apologies for that. All right. If there's anybody out there, could you just let me know whether everything looks okay and the sound is okay? That'll be much appreciated. It should be fine, but I just want to get a confirmation just to make sure. Okay, let's just hope that everything is okay and you guys can hear and see me fine. We'll be soon joined with Khalil, and then we'll get started with the roadmap that we were planning to talk to you about. And thanks a lot for all the votes. Okay, great. Thanks a lot, Sohi. That's great. Thank you very much for confirmation. Yeah, so Khalil will join us soon. So while we're at it, so we collected the votes for the model that you guys would like us to develop and deploy. So we had distributed the poll across the MLDon's Twitter channel, LinkedIn, as well as the post section, community section of YouTube, on the YouTube channel's community bit. And the results were interesting. Not many people voted, but of the ones who did, first of all, really appreciate it. Looks like the number one place is variational autoencoder. Oh, Khalil joined us right now. Hey, Khalil, welcome.
Thank you. Still having a little problem with my equipment, but I'm trying to sort that out.
That's okay. Take your time.
Yeah. I'm invisible, right? Okay, let's see.
Yeah, I can't see you. There's a very strange. Okay, now I can see.
Okay, there it is. Yeah.
Okay,
so, cool.
How are you?
Not too bad. My camera is malfunctioning today, but I guess we'll just use the webcam and see how that gets us.
Well, I can see you perfectly. Everything looks great. So
glad to hear that. Glad to hear that.
yeah. That's one of the disadvantages of having live sessions. Like right now, when I started streaming on Zoom, it was supposed to ask me for permission on YouTube to actually start streaming. It didn't. Just start.
It did surprise me as well. Yeah. But anyway, good to be here.
Yeah, I was just talking about the votes. So I was just saying that we looked at the votes yesterday with Khalil across the YouTube community channel, as well as MLDon's Twitter and LinkedIn channels. And it seems that the number one place is won by variational autoencoders. And the second place was GANs. Now, I mean, we do care about the fact that, I mean, a good number of you guys out there also care about GANs. So with respect to the people who voted most for variational autoencoders, we're going to start with variational autoencoders. But after we're done with development and deployment and everything, we will also add GANs in the future so that other people who also voted for GANs would also enjoy the benefits. And plus, they're both generative models, so there would be some interesting comparisons possible between the two models in the future. So things can get really exciting, actually, if we have similar models deployed. And yeah, and we also, as we mentioned in the poll, the idea is to go over the math concept as well as deployment and development. So it's going to be all the way to the very detail of it, all the way to deployment. And we had a lovely chat with Khalid yesterday, and we decided to come up with a provisional roadmap, and then we could just think about basically share our thoughts about how we think it's going to be structured, and this will give you guys a good idea as to what lies ahead. Yeah, Khalid, if you want to add anything.
Yeah, I'm just happy to be here and excited about today's session. So with both models, the GANs and the VAE that got the highest votes, I think it's quite an exciting set of models to look at, and I'm just excited, to see what comes of it. So I guess we can just take a deep dive into it and get started right away, right?
Yeah, absolutely. Cool. So in terms of the roadmap,
yes. So I'll just kind of share my screen in a second so that we walk through what the roadmap looks like.
Let me enable share. You should be able to share now.
Okay. Okay, so
we can't see your screen. Okay, yeah, now we can, yeah.
Okay, good. So hi everyone, it's good to be back here again. And as Meheran has said, we've been looking into organizing the series so that it gives you the best value for your time and also the excitement that we're looking for from building this model. And this is the provisional roadmap, essentially showing the steps we will take to get from alpha to omega, which is from the model conception to the model deployment and operationalization. Now, they look like a list of points, but they aren't just random points put in that order. There's a strategy for coming up with these models, and it's called CRISP DM. So CRISP hyphen DM. And it's a common methodology that is used for structuring machine learning and data science projects. So if you want to look that up, it will kind of give you a hint on how you should go about organizing your projects going forward. And under each part of that particular workflow, which is sort of circular in nature, cyclical in nature, you could expand on each particular unit and add little steps in there. So I have gone ahead and taken a lot of inspiration from the CRISP DM, and this is what it looks like. So the first step would be data understanding. On this particular part here, Mehran will take the lead. And what we're hoping to do at that point is, before we even go into the model, we have an idea what model we're going to be focusing on. We will start looking at data sets that might be good candidates to demonstrate the utility of the model. And we'll just do a little analysis on the data, talk about the data, give a good reason why we're choosing it. And once we're happy that it's a well enough data set for us to move on, we will jump on to setting up our development environment. So our development environment is actually key because we're not building in the cloud, we're deploying to the cloud, but we're building locally. So we'll talk about things like how to set up your virtual environments, how to set up Docker if we're going to use Docker, how to set up PyCharm or Visual Studio Code. It's very important because if you get this setting of your dev environment well enough, it sets the stage for deployment in the future. So that will be covered in the next step. And it also ties in setting up things like our GitHub projects where this roadmap is going to live, and then also just the GitHub repository, structuring directories. So we'll have a good understanding of the lay of the land to which we will build solutions on in this particular step. Then we'll jump into data preparation. So in many cases, you find that the data is a bit, it needs a little nudge here, a little push there, a little massaging here just to get it to be in shape. So this purpose of this step is to go through that and to get it into the right shape. Then this is where the meat of the problem gets chewed upon by Mehran and dissection and all the animal analogies for a vegetarian. But then, yeah, you use dissector. But then again, I think you can dissect spinach, you can dissect plants as well, right? So this is where the bulk of the work is going to happen. Mehran is going to go over the models we've chosen. We're going to design it upfront. And the idea is to start from the concepts, break it down, go a little deep, look at the key mathematical aspects that are necessary for you to understand it. Because once you have a good understanding of those models, it makes it easy for you to implement them. And while we're discussing the concepts and the math behind them to just a deep enough level, we will be building abstractions or hinting on the type of code abstractions we need to get the solutions done. And then we're going to build a model, we're going to do a lot of testing, we're going to do a lot of refactoring, there's going to be a lot of back and forth there. So it's a very, very rich step. After that, we'll go into evaluation. And as you can tell, what gets measured gets improved. So choosing a wrong evaluation metric can be really terrible. So here we're talking about offline evaluation. We're going to try different strategies to make sure that not just our loss function, but whatever metric we're looking at is being improved on. And then at this stage, we're hoping that our model lives in a Jupyter notebook or some sort of code base that allows us to run the model programmatically and get outputs. So we're going to clean up that code in a code review session. And this is very important. Why it's important is, in many cases, having multiple eyes on your project makes it easy for you not to make silly mistakes. So a code review session would be me looking at what Mehran has done, Mehran looking at what I have done, and then kind of going back and forth until we get to a point where we're really happy with each other's code quality, that the code is good enough, it's readable enough, and we can work with it. And then to avoid regression, we're going to add what we call automated tests. And these tests basically are things like when you pass an empty picture, for example, into the network, should the network process it and do a forward parse on it? So things like that, they're like forcing functions or guardrails to make sure that we don't abuse the model. So that will happen in there. And then we're going to set up CI/CD, which I haven't mentioned. So now that we know that we have this test, we'll plug it into GitHub, and using GitHub, anytime we push code to it, we'll try and run those tests to make sure there's no regression. Regression here means we're not going back to a version that was bad in the past. So we just ensure that we don't make mistakes over and over again. And then continuous deployment partly will kind of jump towards this end, but I'll keep it here as CI/CD. And then the very interesting part where we start taking a dive into more technical DevOps area after the CI/CD would be designing an API. So an API, if you don't know, means application programming interface. So if you can imagine that your model is this fancy piece of machinery that has a lot of sophisticated parts, in many cases, users can't use the model right out of the box. So what you do is you embellish it, you wrap it into this really fine interface that allows whomever wants to consume that model to consume it in a very good way. So one way is called the API, and an API is just an entry point, a clean entry point into your model. And in this particular case, it will be served with something like Flask. Okay, so you can think of it as just kind of like a web endpoint that you send requests to, and then it gets you back output. And then we will plug in a user interface. We don't have to, but it's a good practice because we're dealing with images. So why don't we make it visual? So we plug that user interface into it. We wouldn't tinker with a lot of CSS. There are a few libraries that can help us get up to speed very quickly. And then finally, we get into more uncharted territories with deployment, the part that I'm sure a lot of you are a little blindsided on. So if your interest, I want to believe that there are two classes of people in the audience at the moment. One class would be those that are interested in academia. And at this point, you're thinking, why do I have to listen to how deployments are made? The other part will be those that are in industry. And you would by now know that whatever you do needs to get to stakeholders. So deployment is very key there. And maybe there's a third part who is like, I just need to know science. I don't need to know how this model is going to production. Maybe I might send it over to some engineers to handle. Newsflash, in all three cases, academia, industry, and those that are just kind of pure scientists, when you have a task to get done, in many cases, people do not care that it depends on machine learning engineers or system administrators. You will be the endpoint. You will want to test your code. You don't want delays. So it's important for you to learn how to go about doing it. So what does this deployment entail? I'll give you a very quick run, and then we'll dive into it in subsequent sessions. The first step would be, we'll take this API design that we've done, and then we will containerize it. It's just a fancy name. So remember, we had our model, this sophisticated. We embellished it and wrapped it into this really fine box, which is the API. Now we're going to further again, wrap it in another box, which is a container. And you wonder, why should we wrap it in what's called a container? The container, if you leave here today, all you have to remember is that the container gives you an isolated context, or think of it as a vacuum where the model can do and undo. So it basically lives there thinking that it's in some machine, when in reality it's running in within a process or a few processes, depending on how you set it up. So that thing that gives us the containers is called Docker, but it's an isolated context. We'll dive into it going forward. You need to know this is really fancy and interesting. Now, once you create these containers and your model now could run in independent pods or units, we will try and create our infrastructure. So an infrastructure means setting up a separate computer in the cloud being, somewhere in Amazon's web servers or Azure or GCP. And to do that, we're going to use something called Terraform. And Terraform is just a set of configuration files that gets pushed to something, which is another service. And that service would create the infrastructure for us in Amazon systems, or GCP, which is Google Cloud, or Azure, which is owned by Microsoft. But then now you have the infrastructure, you have the containers. You need something to keep checking on those containers. So let's assume we've built the GANs, right? And for some reason, we put it on Twitter, and we have 10 million people visiting at the same time. It does not make sense to have a single model serving 10 million people. What will happen is the model will, freak out and, use up all CPU time. And then, people will get frustrated because their requests aren't getting responses. But because it's containerized, you could run multiple copies of them within a single system or within multiple systems. And then you need to keep checking the instances you've created, those copies. Are they running? If they're not, you kill them, you start a new one. Kill is actually a friendly term in computer science. Kill means you've terminated them. So you terminate them, and then you create a new one. So you can create multiple copies depending on how much demand you have, and reduce it if you have less demand for those containers. So what handles that is called Kubernetes. We're going to dive into that just to a sufficient level that will allow you to talk about it and also to implement it in your own context. And then the other bit here would be, you built your GANs, maybe you built a VAE because you have a lot of time on your hands, and the model now is in the cloud on some server, and it's getting you all the cloud you need now on Twitter, being that, I've just built this VAE and it's working wonders, and GANs is generating wonderful images. What if the model becomes stale? We now have new data and we want to retrain it. Do we start from here and go back down here? No. What we do basically is we automate it, and it will keep checking to see if the errors after requests are made, if the errors are increasing. So if the model is becoming more incorrect with time, then we're going to use either Airflow or step functions to retrain the model with new data. And once it retrains it, hopefully it becomes more accurate. It will replace the other one. And this is the benefit of CI/CD. So automatically this thing is happening behind the scene. And what glues it together would be Airflow or step functions, or together, working together. And then finally, we'll set up observability. And observability is just, think of it as a probe, as a sensor that looks into our model to tell us how our model is performing all the time. Is it drifting away from the performance we're expecting from it? Is the type of pictures we're getting changing significantly? So imagine that our GANs were trained on dog pictures. And then for some reason now we're getting more people posting cat pictures than dog pictures. Our model is going to be performing poorly now because it hasn't seen those cat pictures. So, we need to keep looking at some metrics to tell us how our model has drifted away from it. So we're going to look into that. And that will wrap up, hopefully, the series. But what I should add is each of the steps could span multiple sessions, multiple streams. But the idea here is for you to, first of all, be aware that these processes do exist when you work with people and when you work with stakeholders. The second one is for you to be able to do it yourself, either through memory or by Googling it. And the third one, hopefully, is for it to help you grow in your career, because if you can leave with the knowledge of all of this, then you'll be a huge valuable asset to whomever you're working with, whether it's a research department or some company they're working on, or just yourself even, So this is what happens entirely when you conceive a model to when you deploy a model. Yeah, thanks.
Thanks a lot, Khalid.
Yeah.
Very, very comprehensive, very, very well explained. What I really enjoyed was how you simplified each one of these technical terms in a very easily understandable way. I believe you have a very high ability in terms of being a good teacher. So really, really enjoyed it. one thing that I'm thinking about here is after deployment, after the last item under deployment, what would be the absolute final product that survives through after all of these steps? Like, what is that final thing that we will end up with?
So the final thing will be the entire system and the model artifacts. So there's no single one, it's two things. The entire system would be, you should think of this as a pipeline. It will be this set of steps that you could go back to at any point in time, change them, and then run through them. So just kind of think of them as a workflow that just runs through. But by the time you get here, you would have built a set of components that are working together to achieve a solution. And that's what's called a system. And the data you get at this starting point and the data that is being fed once we deploy it will now be, you can think of them as, I wouldn't call them artifacts per se, but just think of them as additional data that could enrich the model. So it kind of grows. So the artifacts would be the model. The system would be all the little bits of glues we've stitched everything together with. So that's what you're living with. And hopefully it will look like a website. It will have a page you could go to on the internet. You drag a picture, you drop it in, or you choose one from your machine. Hopefully do a little tinkering here and there, and then bam, something really good comes out on the other end that you could show. So that would be a good way to think about the system.
That's fantastic. That's great. Yeah, so guys, I'd like to also take a look at the chat. So Leviathan, if I butchered your name, I'm sorry. Hopefully I didn't pronounce it too bad. This stream is quite helpful. Thanks a lot. You're most welcome. Happy to hear that. And Bayezid also agrees with the points that you were making, Khalid. I think that this is a very nice and practical provisional roadmap, and we can slightly revise if need be in the future. But as for the initial step, I think this is a very great roadmap. And one other thing that I'd like to again remind our viewers of is that, in case you have missed the first session, this is going to be a highly interactive session, right? So most of the things that Khalil talked about here, I have no idea about, right? So if you don't either, don't feel bad at all. I swear to God, I had never ever heard of Terraform, right? So I'm that bad in that area. So don't worry, right? So this is going to be highly interactive. So as Khalil, for example, would explain about all of these things, would the implementation would get started and all of those technical bits. There are parts where Khalil will ask me to do something, then I'm going to just ask, like, why not this? Why not that? How can I do this? How can I do that? So it's going to be highly interactive. As we are interacting together to push this project forward, we will also keep track of the chat box, where we would really appreciate it if you guys also leave comments, put your questions down. If you didn't get something, just put it there. And we will keep track of your messages as well as the progress of the project as we are working through it. Yeah, that's it, really.
Yeah. Yeah, and I should add also that the code and the artifacts, anything that comes out of this process after each session will be on GitHub. And feel free to kind of go up, pull stuff down, have a look. There's also going to be a Git tutorial somewhere within here just to sharpen your Git skills and GitHub skills. But the idea is there will be checkpoints where you can contribute, basically look into it and say, hey, you guys are off track and we need to fix this, or just give us suggestions through code. We'll be accepting pull requests. I'll describe that going forward. Sorry about that. Yeah. So yeah,
that'll be great. That'll be absolutely great. Bayezid is asking, what about a Discord server or a Slack channel? That's interesting.
It is a great idea.
Yeah.
And this means, so yeah, we should look into it. Is there any preference, Discord or Slack? I know Discord is, more trendy now, but Slack is more Gen XC. So yeah, maybe a poll in there. I'm happy with either of them. I'm also on Discord and I'm on Slack, but if there's a consensus, I'm sure we'll look into it, right?
Yeah, sure, absolutely, either of them. But that's a great idea. That'd be one more channel for us to interact with you guys. That'd be amazing, actually. Thanks a lot for the suggestion, Bayezid. Yeah, that's it. And in terms of the machine learning side of things, I know that models such as variational autoencoders tend to be scared of, really, by people who have just gotten started with machine learning. And if you do feel intimidated by the math, you have nothing to be ashamed of. Honestly, it is not the most friendly looking math that you might think. But I just like to let you know that, trust me, we will go over the math properly, and you will understand it really well when we are done with it. Okay, so don't worry about that one bit. And one other reason that I'm really happy for variational autoencoders to have won, is that the components in the math of variational autoencoders are such that if you learn them well, then by extension, you'll be really comfortable with other generative model objective functions that people have been proposing. For example, you'll be more comfortable with GANs, right? Because again, in GANs, you have concepts such as KL divergence, concepts such as taking the expectation of a giant mathematical formula with respect to a distribution. We have the idea of defining distributions, prior distributions, posterior distributions, that all of these tie really well together. So hopefully once we're done with VAEs, you'll be really comfortable with more sort of generative models that you're really likely to encounter in the future. So yeah, I cannot stress that enough. I'm really happy for this series to have started and really looking forward to the next steps. And I don't have anything else to add. If I'm missing anything, Khalil.
No, I don't think there's any more to add, but what I would say is we'll try and set up the Discord. So keep track of what's happening on ML Dawn on Twitter. And as soon as we send that on, hopefully we can interact more outside these sessions, so that, when it comes to kind of like telling you what's going to happen next, you asking questions, we can go through that. I'm really, really excited about, just setting up Discord. So yeah. So that's it mostly. So come next week or come next session, we're going to start getting our hands dirty. So you should be able to see some code. If there's anything we need you to get prepared for before that time, we're going to send it on through Twitter or Discord, so that you come in handy, or prepared just to kind of ask a lot of questions and make it interactive as well. But yeah, more interaction is better. Tell your friends about it. It's going to get really, really cool, and just be part of it, participate.
Yeah. So by the way, guys, you guys see the account, the accounts of social media of ML Dawn in my background. So definitely make sure you'll follow ML Dawn on Twitter. So that's going to be, at least for now, the main line of communication until we get started with Discord as well. And please do share this video with your friends, and also do like and subscribe. Because then the YouTube algorithm would sort of show the video to more and more people. So hopefully more people will be able to get engaged. So it would be a truly massively high sort of interactive stream for all of us to learn and get better at what we do. So that's great. Anything else, Khalil?
Nope. Thanks for showing up, and looking forward to chatting with all of you.
That's great. Thank you so much, Khalil. And guys, see you later, all right?
See ya.
Bye.